I'd like to ask Padraig to come here on stage with me for the next section. Thank you. Padraig?
Yes?
As I set up the panel,
Yep.
you're our Chief Product Officer.
Yep.
So maybe you want to step a few steps forward.
Yep.
Tell me a little bit more how excited you are about launching a new product.
I'm really excited. I mean, I think this is the culmination of a lot of great work, and not just, we'll say, this particular release over the last 9 months, but it's been building over the last 4 or 5 years. So, as we've understood the whole edge infrastructure, as we've understood what our clients were trying to do at the edge, and then figuring out how to actually produce a solution that solved their problems, right? And I think what we'll launch here today is, again, the next generation of how do we help our clients deploy AI models at the edge, because that's what they're all craving to do, and we're basically making that easy for them.
Excellent. Well, Padraig, with that, I want to hand it over to you for our next section, which is a very exciting panel. Thank you
Very much.
All right,
Excited.
thanks.
Good stuff.
Very
Thank
good.
you.
Thanks.
All right. So I'll ask my panel members to join me, please. Thank you. I know it's a tough act to follow, but we'll do our best. Yep. Thank you. All right, so I want to thank my distinguished panel members. I want to thank you all for joining us here this evening. And so we'll start, actually, and maybe we'll do a quick round of introductions before we get into the questions. So, Mohammed.
I'm Mohammed Ansari. I'm from Qualcomm. I'm in the Industrial and Embedded Business Unit, working on industrial solutions.
Hey team, Bridget Martin. I'm at SNUC. I'm our solutions architect, designing complex edge systems.
I'm Dev Tyagi. I'm president of the UK, Ireland, India, and APAC. Sounds like a big territory for Submer Technologies.
And I'm Sami Nassar. I'm CEO of SecEdge. I'm sure a lot of you know about SecEdge. It's a startup, and we are mainly focused on digital security. We are known for AI model security.
So thank you all for coming. I think we got a great cross-section of different parts of the edge space, actually. So before we get started, I'd love to get your guys' perspective on where AI is at the edge today. How do you see, if we set a kind of a baseline, what's actually being deployed? How do you see it? What value is it bringing to our clients today?
Yeah, I'll go first. What we are seeing is we have our platforms, the IQ series, that power the edge gateways and edge servers. We are seeing computer vision deployed quite massively. And now computer vision applications as well as LLM integration so that you can reason the scene and you can interact with the system. We're seeing that in surveillance market. We're seeing that in manufacturing and inspection. We're also seeing real-time series use cases along with computer vision, like flare detection, for example. We're doing that in the edge. Qualcomm's IQ series combines NPUs, GPUs, DSPs, and CPUs. So we have like a hybrid compute program. And so all of these use cases that are mission critical are slowly beginning to be deployed, although they are early stages. Yep. I would say that we're going from recognition, object recognition, to closed loop decision making. And that's what the journey we're trying to enable.
Yeah, I agree. And then Syed had mentioned earlier, we are in that transition period now where it's not just proof of concepts. We're moving into full-on production in a lot of these deployments as well. And it's just so exciting. But as part of that, more and more compute at the edge is required in order to do that. And so being able to provide that density of compute and performance that you need in often hostile or not easily accessible locations is becoming more and more critical.
Sure.
I guess I'll be a little bit controversial because I think the edge is completely changing. And I think we don't really know what the use cases are yet. So there's very traditional use cases like computer vision. So I agree with everything that's being said. I think what you said about CPUs and NPUs is really important because that's a heterogeneous computing environment that's happening at the edge. And I'm not convinced that everybody knows how to handle that. And actually, I think this is where this partnership is really important because I think ZEDEDA absolutely understand how to handle that. In fact, I was having a chat with the CTO earlier, so I'm super convinced now that this is exactly the right platform. So I think Edge is definitely changing, and we're at a pretty critical inflection point. I think some of the announcements that were made today about inference, taking over, and of course today's announcement here really underlines that.
Well, the biggest deployments today are in self-driving cars, right? So those are like existent today, and this is only a sample of what's coming. We see a lot in industrial. Vision AI is something very concrete today because it solves problems that linear code cannot do, and it's providing a tangible value towards the different type of capabilities that these machines can do.
That's excellent, thank you. So one of the things I think is quite interesting, and it kind of goes back to what was said at the conference today around, it's the inference, tipping point for inference, right? And so we believe that too, and we see that when we talk to all our customers day in, day out. From your perspective, what's changed now that people are moving from kind of pilot, R&D to like deployment and production of these technologies? What's the key at the moment that's driving that?
So, I'll talk about the industrial segment, especially the critical infrastructure and critical industries. We see three things that are driving adoption more. One is cybersecurity. There's at least a perception that the OT edge is insecure. And the other thing is determinism and latency. That's driving the adoption. And the third thing is how do you reduce the cost of computation? And cloud has higher cost. So those three things are pretty much driving people to look at this. And obviously, ZEDEDA is focused on security first as well. So I think there's a very high synergy with the platform you're building, not just for AI, but also the OT edge.
I get so excited when anybody talks about inference. I've been in the edge space since it was called embedded, or at least most of it was called embedded. And so inference is now that we've finally gotten to this point where it's primarily inference, and yes, the training is there and the hype is there, but inference happens at the edge, and that's because that's where the action can take place. But what's really moving deployments into production is the availability of models that they can tune to their use case, the data that they have available to them, but then again, the compute, the accelerators, being able to deploy that into real world environments.
I agree with that. I think the adoption comes from the amount of data that's being created, right? There's a huge amount of new data that's getting generated, and as I said earlier, I don't think we even know what type of data is going to get generated in the future. And that's why we're at this inflection point. But I think that adoption is being driven by the amount of data, and the amount of data that's being created is being created at the edge. So latency is really critical when it comes to being able to process that data. And I feel that, really, if you then have models that can adapt to that data, you are going to have the use cases that get built. So I think that's really what's driving the adoption, and the infrastructure, of course, has got to keep up with it. And of course, that's what we're all about, to make sure that these NPUs and CPUs can get deployed into remote locations, and they can be liquid cooled, as we've discussed. We don't want to use water if we can save natural resources. That's really important, and lower the power that's being used to actually run those models, which is really difficult when everything has come from centralized large-scale data centers. It's a completely different paradigm when you move to the edge.
Actually, I will answer this a little bit differently. There is a big driver, which is excitement. People realize how much more they can do than the traditional linear coding. Capabilities that were unbelievable to a certain extent in the current compute paradigm are now very easy to deploy. I think everything else is a resistance. Cost is a resistance, security is a resistance, reliability is a resistance. There's a lot of problems that you need to overcome, but there's a lot of excitement of how much capability you can bring from not only into the cloud. We're still excited about what's happening in the cloud and the AI. Now we start seeing it in real objects in physical AI, and excitement is even building further and further. So there's a lot of push, a lot of creativity, a lot of people realize that they can do so many things, and so much investment is going into it that the push is very hard. Because now we have to overcome the resistance. Is the security there? Is the reliability there? Is the cost acceptable, and so on?
So I'm going to stay with you, Sami, because I think one of the areas of resistance, to use that term, is actually security, right?
Oh, absolutely.
I mean, so our experience is that the security requirements of all our customers, Fortune 500 and every customer is extremely important in this day and age, right? They want to be certain that their devices are secure, their data is secure, their network cannot be hacked or taken over, etc. When you think about the world we're moving into around a lot more AI models, a lot more agentic type stuff, how do you think about the security aspects and the security challenges that we have to overcome?
Oh, it's pretty big and it's pretty substantial. It's getting the stakes are getting higher because right now you're not spending a few $100,000, you're spending hundreds of millions to train your model, and all your IP went in there. A lot of hard work, a lot of intellectual property that if that constitute your product and your wealth to a certain extent can be copied in a moment. And that so right now you have this very valuable piece of code, to say a model, that is vulnerable. It's at the edge. If it copied once or somebody can copy it, it's gone. So now the protection of that IP becomes critical. So that's one side, like this is for business production. The second thing is about now this IP can do a lot of things. It could be dangerous. So now that because it has a lot of powers, a lot of capabilities, it can harm. So safety becomes a concern, and alteration of that model becomes a concern. So for us, security is not only about preventing people from copying or protecting the intellectual property from that AI model to be stolen. It's about preventing its alteration, preventing unauthorized changes, because it has a lot of implication in the real world.
Yeah, I think this also plays into the hardware side of it, right? The infrastructure
Oh,
side.
absolutely.
You have to prevent any bad actors sitting on your system. The hardware today is very underrepresented when it comes to security, and we see lots of technologies that have been announced by all sorts of companies. The big ones, of course, talk about their trusted zones and so on and so forth. But I think it's add-on technology, actually, like secure TPMs, which are going to be really, really critical. And they need to sit in the hardware. And I think the next stage will be in BMCs, right? Base management controllers. I think that's a critical component that is completely overlooked. And then deploying all those updates in a secure fashion is really, really hard for most operators. And as we move this out to the edge, I think it becomes even more difficult for them to be able to manage that.
Right. Yeah. So Bridget, I see you reacted very, very well to one of the...
I was just going to say, you won me over with your BMC comments. I really think that out-of-band manageability is going to become more and more critical, especially as we're deploying more of these models out into the edge space, whether it's for security and protection reasons, like we might be having now.
No idea. Yeah. All right. What's he today?
It's a hot conversation.
I guess someone's trying to get in without paying, So the bouncer will look after it there. So, all right.
Should we just talk through it?
I think so. Yeah. Go ahead. Yeah.
Last thing I'll say is that in order to maybe do things like this and remotely be able to turn that off.
Yeah. Well, we were actually talking about security, and I think it's quite apt that we have. Mohammed?
Yeah, I think everything that they said. As Qualcomm, we are very interested in securing the software. Yeah. The image that we ship on the hardware that has to be secure at the edge. The hardware itself. Any sensors that connect to the device, they have to be authorized. Yeah. But also we're looking at how can we do models and data that for inference into that model on a trusted island, right? Yeah. And that's secure computing that's still evolving.
Absolutely. Yeah, absolutely. Thank you.
Let me add,
please.
Yeah. Because there's a notion there that could be valuable to look at, which is a notion of ownership as well. Okay, who owns the device? And who owns the AI? It could be two different owners. And going forward, the robot itself or the car itself could be like a hardware machine, and then the brain is done by a completely different company. And you need to isolate the device security itself from the AI model security because it could have completely different ownership. The AI model on its own needs to have its own life cycle management. And it needs to be always, like, for example, if we talk about encryption, it's encrypted after simulation, not when it gets into the product. This is where you assume the ownership of that AI model, and it's authorized to play in a certain device. But the application that's running on the device shouldn't be able to see the model. So we're separating of ownership between the hardware and the software, in this case, the intelligence, is something that is very critical in this model too.
Yeah, I think to your point, there's just more layers now. Like, we used to have to manage the hardware, manage the software. Now we're going to manage the models from a security perspective. So
Yeah.
it gets more complex, right?
Yeah, just one more layer.
Yeah. So when you think about, you talk to folks, and there is different degrees of success of taking a project from pilot, from lab out into production, right? And I think there's probably different reasons why people recite as to why they struggle to get it into production. But I'm curious from your perspective, right, what you guys see. What do you think are the main challenges, the things that people maybe miss, don't think about ahead of time, but what are the operational challenges that make it difficult for them to take that great idea in a lab and actually turn it into something that's mass deployed?
Yeah, I think deployment challenges, there are some developer-oriented challenges or remote debug challenges, but deployment challenges are really very important to address, and especially at scale, right? And so what we're seeing is people, especially the industries that are OT industries, they want a separation of OT and IT data completely. So OT and IT separation is a deployment challenge. You can't just prove it in the POC on the lab. And so that's the number one thing that we see people are very sensitive to. And also in terms of scale, how do you manage 1,000 gateways or 1,000 nodes at scale? And I think that's something you know something about.
Well, the answer is ZEDEDA.
Yes,
Well, that's okay.
Exactly.
Yes.
I was going to say something similar, and then it was already mentioned some of the standard resistance, I think you called it earlier, which I love. But it is that connection into the components, I would say, that are just outside of that POC or that thing you did in the lab. I think a lot of times deployments don't fully think out, what are the systems that are just on either side, and not necessarily just physically, but logically as well. And so really needing to have this concept almost of bolt-on AI, where you're not having to rip and replace your entire infrastructure and system, but that it is cohesive with your other upstream and downstream processes, is what I have seen some of the major differences between what's been successful into going into production and what stays in the lab.
Yeah, I think trying to slide in on top of what you got as opposed to that is a huge.
Yeah.
Yes, I agree with that.
I think sometimes it's right place, right time, right? I think there's technology that's out there. It's just been too early for adoption. And then there's technology that's out there that's been too late for adoption. So if you hit the right inflection point, and we have a great example at Submer where we have a cloud gaming application. And if you take a look at the history books and you take a look at what Google was doing with Stadia, and AWS kind of tried to do this, Microsoft, of course, have their whole infrastructure. But actually, now is the right time to deliver an amazing customer experience, because the latency problem, as we move this to the edge, disappears. So your customer experience is incredibly high. So we have like 70 odd telcos, I think it was alluded to earlier, right? We've got 70 telcos that are signed up with us through a company that we loved so much that we bought them. So RadioNarc is a company that we acquired. And they have a cloud gaming platform which uses GPU technology. It's not yet an AI application, but you can see how AI is going to be applied in gaming. And we're already seeing these techniques where you have a pipe, you don't want to move data down that pipe because that's expensive. So you can use AI techniques to then put a 720 stream and you get high definition, 4K out the other end, which is at the edge. So I think it's right place, right time sometimes. It's not always about, other challenges. It's just making sure that you're taking advantage of new software stacks, new hardware, gluing it together and going out and delivering it.
Absolutely, there's a lot of challenges. One additional one that, if I may add it, is if you look at all current software is deterministic. systems are deterministic. They will behave in the same way if you put them through the same experience. AI is not. How do you test it?
Yep.
How do you know if it works? So I think how the precision is one of the biggest factor now that's playing, resisting deployment that are sensitive, because the precision is still need to improve. If you look at, we know that we will have a great humanoid robots, but if you see them walk now, it's not that well. So it's coming, and we know it will be very exciting, but there's a lot of obstacles on the technology itself as well that makes it maybe ready for something simpler today. And as we evolve in terms of how we can assess its stability and its precision, we can go even further.
I think that is true. When I talk to folks in different verticals, I see a different degree of nervousness around deploying some of these solutions depending on which vertical you're dealing with, right?
Even in your car, if you try your self-driving car, the first time it's like, are you sure? Is this thing gonna work?
Very true. That's very true. That's right. So as we look forward, right, so a lot of discussion this week, and not just this week, but leading up to this around Gen AI, but really when we get into the real world, a lot of AI today is computer vision, prediction, right? So, and we think about like Gen AI, we talk about small language models, visual language models, particularly in the edge, right? How do you see the gap between the reality today, what people are doing, versus what you think the hype is and where they're going to go with this technology?
I think we are beginning to see the beginning, it's very nascent, is continuous optimization decisions at the edge with the AI. And somehow that also informs an actuation event or a physical process. And today that's not happening autonomously because no one trusts AI that much, especially in critical decision making. What's happening today is some of the edge intelligence is informing an operator and advising an operator to change the set point, for example, of a PLC. And so that advising and that sort of corroborating effort is what people are sort of deploying. But at the end of the day, I think it's going to be reasoning and making decisions autonomously, which is where this is going. And for that, I think the point you made, AI need to be explainable for liability reasons at the minimum. Drift of AI models need to be corrected at the edge, which is not happening today. And so obviously those are things that are still early stages.
Bridget?
I think it depends on the use case. I think those examples that you mentioned, very much going to be the case. I think probably still for a while in a lot of manufacturing, a lot of critical infrastructure, but I think we're going to start to see more and more deployments in closer to consumer level deployments, like the quick serve restaurant space or the retail space. I can very much see, especially with some of the exciting agent-based technology that's coming out, more and more deployments within the next year.
Yep, for sure. I think so.
I guess you kind of got to align it to human behavior right, as well. We make mistakes. Why are we expecting, AI, agentic AI, for example, why are we expecting that to be perfect? It may be critical, right? So we have to kind of weigh up the balance, right? If it's a critical decision that's being made by an AI agent, do we really want that happening? As to your point, do you trust your self-driving car, right? Right, but that's the point, right? So if we make the mistake, we are happy to throw somebody in jail, right? Happy to take them to court. What do you do with your AI system? Do you take that to court? Do you go to an insurance-backed guarantee from some insurance company that's going to underwrite it? So I think we have to be prepared that there's going to be critical and non-critical differentiators when it comes to these kind of deployments. And we have to be ready to accept that if we want AI in our lives, and we kind of have no choice, right? It's already pervasive, it's here. Then we have to also be ready to make those decisions. And I think we're going to see a huge sea change in how lawyers work, how insurance companies work, and it's going to come into our space, right, as well.
So I don't know if we are at the hype level that we could be. I think it's still people, and I look at my family. When I show my wife something, she always says that no, that couldn't be right. So I don't think they are at the level of maybe we are hyped more than the average consumer today. But you're right in terms of for edge AI, the challenges are pretty substantial as we go into that market, and we might be getting more resistance than we're thinking right now, just based on the challenges that we need to overcome.
Yeah, because it's really interesting. We have the whole agent AI software coming, right? And I mean, this stuff is really cool. There's no doubt about it. The more you play with it, the more it actually amazes you. And so I think there's a fantastic power here, right? But I think the question is, though, right? How do we manage it? How do we deal with the security issues? How do we deal with the risks that go with this superpower, to use the expression Saeed used in his presentation earlier? Like, what are the things that we need to do to ensure that the adoption goes forward as opposed to get stalled because of resistance from our customers or consumers, that it's just too risky?
Yeah, first of all, I think it's getting deployed where the ROI makes sense, right? I mean, people are going to look at the return on investment, and if the use case really helps financially or operationally or security-wise, how do you manage it? You have to go in stages, especially the industries I'm referring to. Maybe the next step is advisory AI, and then at some point you have to sort of integrate AI with physics-based models as well, so that it provides an envelope, a periphery within which AI can operate, and outside that envelope it can't. And then eventually you trust it enough, and you have enough reliability built in to the AI models. I know companies that have been training an AI by monitoring another AI monitors the AI development, right? And so that way you understand what layers of decisions are being encoded. So it's a journey, and I think it's going to be regulated and deployed in a very precise way before we let it loose.
Hopefully.
I was going to say that's such a big question. There's a lot of societal aspects that go into it, but I think from intellectuals and engineers who are deploying these solutions, just being conscious about it, thinking about those workloads, understanding, are they going to be critical workloads? Is that going to be deployed in that kind of situation? And then doing your best and making good judgment, making it as explainable as possible, and using the tools that you have available to you. Having that out-of-band manageability if it gets out of control, ensuring that you're running in trusted execution type environments so that you can control it if it goes awry.
Yeah, I think explainability, transparency is huge, actually, yes.
I think there's a clue in the question. Because you talked about playing around.
Yeah.
And I actually think that's really important.
Yeah.
You have to play around with technology. You have to play around with the models. You have to play around with the silicon. You have to see what's on the roadmap. You have to make sure that your playground develops into something truly usable. And there has to be some money at the end of it, right? And to your point, let's not lose sight that this is part of the reason that we do these things. So I think you have to have a playground. You have to then make sure that what you're producing is a finalized product. Nothing is ever final, right? You always improve things as they get into the field. And you've tested it to the nth degree based on the technologies that we have available to us today. And I think if you've gone through all of those, milestones, you have more confidence in that deployment. And you're taking less risk. But life is nothing but risks. So no matter what we do, there's always going to be something that happens, which is why our iPhones get patched every 2 weeks, I think is what it feels like at the moment, right?
That's true.
Right? So we're making these improvements on the fly, but I think you have to get to a certain point where you say, you know what, I've done everything I can, I'm ready to deploy, and then you go back into your playground and you start again with something else.
One other angle to answer the same question is today, if you look on how much investment is going into this field, you realize that there's a lot of brains working on it, and ultimately it solves it. And that's actually one of the, if you look at all segments in the industry, the one that makes money get investment. And today there is a good belief that there's a lot of money at the end of the road. So a lot of people are pouring a lot of investment, a lot of good people working on these technologies, among them all of us.
Yes,
And
right.
I think all these problems are something that we're conscious of, but there is, you know, the goal and the number of people is there to be able to overcome it all.
Yep.
So I am very much more positive about this.
So I have to ask you a question. Sorry, I know this is
Please,
your
no,
job- this is
please,
your job.
absolutely. I've loved
But
that.
I have to ask you a question, and the
Yeah.
question is, you talked about there's a lot of brains that are working on this. So my question is, what is the percentage of human brains that are working on it? Right. And what is the AI brain that's working on it?
So AI has started to work on, like Jensen did mention today that they are using AI to optimize
Absolutely.
some of their processes too. So we'll take the help when we get it.
Right.
So, but we have enough brains to, that's the main idea.
It's true. A lot more we are relying on the AI brain for sure, right?
completely.
And the reason I use the expression play around, because I think you actually have to use it to really understand the power of this technology, actually. You cannot learn it from just reading about it. I think you have to experience it, actually.
So AI will help us build better AI.
Yeah, very
And
necessary.
at a certain point, we might be irrelevant, but that's
true. That's true. So final question, really. I think before we finish up, and then we'll open up to questions from the audience. When you look forward, I think what excites you most? What's the biggest challenge, and what excites you most about what you see coming down the pipe?
I mean, it's almost like it's hard to imagine what can happen with AI. The speed with which things are changing. I mean, it's almost scary at times to think how would life be impacted, right? Our personal lives and then our business life and our commercial, industrial operations. It seems like everything is up for redefinition in some way, right?
Absolutely.
It's hard to be excited about some of the dangers that could be lurking around, but obviously, you know, assisting human beings in making decisions, lowering risk is something that I think will be the eventual promise of AI if it works right.
Yeah, totally.
It's robotics for me. Just watching machines move on their own is just always going to be fascinating, I think, to me. And then as we deploy more and more of these things, watching something that came from one company or one group interact with something totally different that was outside of it is very exciting for me.
Yeah, I agree.
I think it's a really unfair question.
Yeah.
That's why I ask him. That's why I'm not answering. I'm just asking.
And I think it's really unfair because everything is exciting.
Yes.
Right? If you're in technology today, everything's exciting. And I wish I still had another 40 years in me, right? Because I think at every turn, there is a new invention. Yes. And you know some of the things that I think are really exciting today are using agentic AI to create new forms of silicon to drive adoption of AI, right? It's a really weird place.
It's like a flywheel, perpetual motion almost.
It really is. And I think that that excitement, from our point of view, of course, informs us what infrastructure needs to go into the field, and getting this sort of technology into the hands of the people who live in the remotest areas, and democratizing, technology for them is an incredible empowerment. So I think the tools that we have, if we can do that, we're going to make much better society. So that really does excite me.
I'm exactly like you, and everything excites me, but much more because I graduated in 1992. That's ages. I'm pretty old. So in 1992, I had a master in AI. And I had a dry spell in not being able to do anything since then until last year, right? So timing was off. So seeing it right now come to fruition is like, it's really exciting.
Dream come true.
Yeah, I agree. I agree.
I didn't think that I would see it in my time, but
I think just the what's possible now has just been totally redefined, right? I think everything seems on the table now going forward with this technology, which is really powerful but really cool. I think it's an interesting time we live in, which we've always been said, may you live in interesting times. So I'm going to open up to questions from the floor before we finish up. Any questions? Any comments for panelists, please?
I'm Nikunj Mehta from Falconry. So one question that I've always been bothered by is some of these industrial applications do not tolerate change very easily. And yet we live in times when things change faster than we can even imagine. How do you see that tension playing out as we roll out AI, and especially in production?
Well, without naming companies, we see there are companies that are very resistant because they've deployed a solution for 10 years in the field, whether it's an oil field or whether it's a plant, and they just don't want to change because nothing is broken, so they don't want to go to a new stack or a new way of solving the problem. So there is that type of players, and there are players who are willing to take the extra step and sort of confine the new, especially the AI technology, to a particular use case, to a particular set of optimization rules where they'll apply it and then deploy it safely just for those use cases. So we're seeing both resistance to some degree for those solutions that are in the field for 10, 20 years. People just don't want to take a risk, to people who want to try in a very measured way.
Yeah, I honestly don't think it's any different than a standard adoption curve. It's just that the industrial space works a little bit slower than some spaces that we're more used to engaging with on a daily basis.
I would say as well that people who are too resistant suffer the consequences. Competition drives adoption of technology. If someone is stuck in the mud and says, you know what, I don't need this, somebody else is going to adopt it and they'll get the competitive advantage. So I think, whilst there's definitely these use cases where we're kind of stuck because we're in an oil field and everyone's doing it the same way, I do think that the adoption of new tech is what's going to set apart different competitive streaks in the industry. And all of us kind of being in a technology world, we should be used to that.
Yeah, so every industry have its own cycle, different speed, right? If you're talking about consumer electronic, it's very different than in automotive, 5-7 year cycles, or industrial, someplace in between. So those industry have their cycles, and they will stick to their cycles unless there's a disruption. And that disruption will depend really on the application, very specific. If some new comer come in with a disruptive technology, they'll have to adapt. Otherwise, they will go with their flow and stay with their cycle.
That's true.
Yeah.
Olivia Rakshit, Avesha. My question to the panel, so NVIDIA announced something called the AI grid today. So I was reading about it, and I was curious what the panel thinks from an edge AI perspective, and Said talked about distributed AI. So what I understood from their announcements was, the workload will be placed on the right compute or the right edge. And so that workload placement, and how does the panel see in a distributed environment? Is that a current use case, an active use case, or how do you go about that?
That's a question for you.
Okay, well, fair enough, I'll take that. Yeah, I thought that was a really great concept, and it's actually one that we've embraced in ZEDEDA prior to this, actually. So what they're really talking about is, like, in this new world where we have agents basically deployed, those agents will get deployed on the particular node responsible for a particular task. And so it's not as if you're going to have a generic piece of software deployed across all 50, 100 IPCs in a plant, in an oil and gas platform, etc. You will have specific capabilities deployed at the point where it's actually needed within your operation. And then I think you'll end up having layers where you'll have agents with specific tasks, you'll have agent supervisors that are monitoring, and then you'll probably have a back-end LLM that's helping the agents make decisions on how to deal with whatever sensor data, whatever has changed in the environment around them. So I think it's a really powerful concept. It's early days, but I do see that in the future and being deployed widely. I've been watching and listening to my panel. I've been learning. Please.
Hi. By the way, great presentation. My name is Ashit Ghevaria, passionate about the edge AI. So one thing you all spoke about is about the latency. And for the latency, the typical things from the demos and everything I saw is in seconds, whereas in several critical applications like mobile edge or surgical, it's in sub-milliseconds or microseconds, and the agent itself takes several seconds. So what do you think we can do in terms of innovation to bring the end-to-end latency below milliseconds? That way you can enable those applications as well.
I can go. Please. So our Qualcomm's platforms do address millisecond latencies, in some very few cases, microsecond latencies as well. But for microsecond latencies, you really need a dedicated ASIC type hardware. And also there are several other parts of the system that are not AI related, For example, the interconnect bus on the chip, the cache, the shared cache between the cores. All of those need to be optimized in a way that different workloads can share the CPU clusters, and there should be a very efficient scheme to share the cache, for example. And then the interconnect needs to be used in a sort of a dynamic manner, which not all the systems today do. On the NPU side, where the AI runs, you have the same challenges, because NPU also shares certain IP in the system. So that also has to be figured out as to how that sharing works to bring the latencies down. But more important than latency is also, in some applications, jitter. So the variation is extremely critical, and that one time that the variation is outside the curve can be disastrous, right?
Yeah, it's almost trying to get determinism at a couple different levels, having the determinism of your agent and not necessarily always knowing what the agent's going to be producing, but it's always going to do it within this certain amount of time, and then managing that within your hardware architecture.
Yeah.
I think it's also about the definition, what is the edge, right? Because the edge doesn't have to be at the end of a telco line. You know, the edge can be in a hospital. It can be a completely self-contained system. It still needs the same software, it still uses the same agents, it still uses everything, but it's dependent, you know, surgery is a great example, it's dependent on instantaneous real-time responses. You definitely cannot do that if you're going back to a cloud or a network or even a telco edge. It's impossible to have that type of response. So I think you have to define what your edge actually is. And in a hospital environment, your edge is very close to surgery, right? If that's where there's a surgeon in India, in Ahmedabad, who does 7 operations, right? I think they're knee operations, I can't remember what they are. It's completely self-contained. His system is right next to where he's doing the surgery. And that's the only reason he can complete those 7 surgeries in open theater, essentially. So I think you have to define what you mean by edge. Everything else stays the same. The software stays the same. The agents stay the same. The GPUs are still the same GPUs, or with accelerator technology. You're still offloading. You've got to get your jitter absolutely 100% agree. I mean, that, all of those technologies exist. You've got to deploy them at that particular edge location for that particular service. So I think it's a canned environment.
Actually, moving to the edge improves latency, right? So that's the first step. Like, as you move the compute to the edge, you get much better latency. And then, the industry is very good in making things faster and faster every year. While waiting for that, probably a lot of systems will adopt some hybrid where, some deterministic things that are very sensitive towards latency will stay as they are now. And like maybe AI goes someplace else. So I think the industry will solve that problem as time goes by. AI will not be good for everything from the get-go. It will take stages, and the first stage is moving this AI into the edge.
Great. Okay, thank you. Any other questions? Going once. Oh, sorry, at the back here. Yeah, please.
Yeah, this is a great discussion. I'm Chandler Heath with Worldwide Technology. We're actually talking to ZEDEDA for some very large implementations. I just saw something on OpenClaw today, in Jensen's keynote, and I'm curious how everyone on the panel, or if there's a consensus on how we respond to these kind of disruptive technologies. Somebody comes up with something like OpenClaw, which has very, very significant security implications, performance implications. Now, I have people talking to me about, we want to deploy this in manufacturing, right? And it's like, we just heard about things don't change fast in manufacturing. How would you tell somebody who's interested in kind of deploying something like that, something disruptive like that, with the technology that each of the panelists really support or, have them?
Yeah. Set up your digital twin, make sure you test it, and then go and deploy it. But don't just take something that like OpenClaw off the shelf and assume it's going to do everything you need it to do without introducing problems, let's put it that way. So I would say you have to really have a closed environment, test, 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 then deploy.
Yeah, I think that's true. And like, it's the way I think about it, like you cannot just take something as given and deploy. You have to understand the technology, understand the pros and cons, and figure out how it applies to your particular industry or your particular use case, right? Because you have to own the decision. You can't rely on some guy blogging something and saying this was wonderful. Everyone should be doing it, right? Humans still have responsibility for making decisions. We should retain that, I think, control.
I'd highly recommend a threat model.
Please.
Yeah, I'm not trying to throw a softball to us, but you mentioned BMC Dev. Can you explain the actual impact and the benefit when rolling out Edge AI?
I think BMC is everywhere, right? So it's in the data center, it's on the motherboard, it's in a number of different components, right, that you have. And if you're not, it's well documented, the BMC is compromised. Okay, so that's something that we have to accept. You have to close those compromises down, and you have to make sure that there is no potential infiltration that's happening through any component inside your system. I'm talking about it from a hardware perspective. Of course, there's all the software protections that need to exist as well. So if you don't have your BMC under control, you're going to have potential access and threats coming in from third parties into your infrastructure, which you don't want to have. So the BMC is a critical component that is not treated like a critical component today, and that has to change.
Well said.
Thank you.
Can I ask a question?
Please, yes.
You said the BMC is compromised. Is it
Yeah,
at the spec level or at the implementation level?
at both.
Okay.
I'll send you the papers.
Yeah. I like that. This is an opportunity, right?
Yeah,
Indeed.
Well,
If
some of
they-
the work that you're doing is actually going to help fix this, right?
Yeah,
So,
well, absolutely.
All right, great, thank you. Great questions, by the way, thank you. Any other questions? All right, well, I think we'll call it a wrap. So I want to say thank you to my distinguished panel. You guys were awesome, really educational. I learned a lot here tonight by just being up on this stage with you. So I want to say thank you very much for your time and for great insight. Thank you.
Thank you.
Let me. So I will ask Saeed to come back to the stage and to bring us home. And we will go from there.
Thanks so much. Thank you.
All right. Wow, that was really exciting. Thank you, panelists. Put it together for panel. Thank you. I want to also thank all of you. I know there was a lot to cover today, so I appreciate everybody's attention. I hope you found it as informative as I found it. We're excited about today. We're excited about the launch. We are really at an incredible time. I think it was said at the panel a few times. We live in very interesting times. I think very exciting times. And I think we're still at the beginning of what I think is going to be the next big wave in AI. We look forward to do that with you, all our investors, partners, customers, team members, and Fozzies. And thank you with that. Please enjoy some more food and drinks, and see you soon. Thank you.